As we know, autonomous guided vehicles or unmanned vehicles are gaining importance in various fields such as defense, space exploration, recovery, extraction, excavation, etc. These are also vividly used in industries for material handling and transportation. For these applications, there is a requirement of input from multiple onboard sensors in order to function as intended, as well as good communication between the host and the vehicle. Now, let us make a block diagram in order to build this system. The block diagram consists of two ultrasonic sensors and an IR sensor, which are used to take the readings of the surroundings. This is connected to the 4 differential 8 single-ended inputs with bridge board, which will be referred to as the I/O board for the rest of the video. We are using this board to interface the sensors with the processor board. Further, we connect to the processor board, which is the ESP32 processor module. It processes the data from the sensors and sends it to the mobile app, that is Dabble. We then proceed towards the motor driver, which drives the two motors that are connected. We are using Bluetooth as a medium for establishing communication between the mobile app and the stack. Here, the sensor data is sent to the mobile app and the commands to the vehicle are given using the app. Boards that are required to build this system: ESP32 rover processor module, USB-based low-noise power supply board, motor driver board, 4 differential 8 single-ended inputs with bridge board. Arrangement of modules according to the block diagram. Here, the green line indicates inputs, red line indicates outputs, the black line indicates bypass, blue line indicates control lines. Here, the upper half represents the I/O signals and the lower half represents the control signals. The two echo pins of the ultrasonic sensor and the analog output of the IR sensor are connected to the I/O board, through which the signals are then passed to the ESP module. The trigger pins of the ultrasonic sensors are connected to the ESP board through the motor driver board, which gets its signal from the ESP32 board. The EXI pin is used to power the sensors. Finally, the control signals to the motors are sent by the ESP32 module.
As previously explained, analog output from IR sharp sensor is connected to the channel 3- and echo pin from two ultrasonic sensor is connected to channel 2- and channel 2+. Ground and VCC pin from all three sensors are connected to ground and EXI terminal of I/O board respectively. Trigger pin from two ultrasonic sensor will be connected in a later stage. To send these signals to the ESP32, we short jumpers OC, OD, OE. And to power the sensor, we short jumper Z. Here, OC, OD, OE get signal from channel 2-, channel 2+, and channel 3- respectively. In the ESP32 board, we short jumpers IC, ID, IE in order to get signal from I/O board. For the trigger pin from two ultrasonic sensor, we short AA, AB. Next, AC, AD, AE, AF are shorted for motor driver board. To activate the EXI terminal, we short jumper Z. In the motor driver board, here we are using two bidirectional motors. Motor 1 is connected to terminal channel 1 output 1 and channel 1 output 2. Similarly, motor 2 is connected to terminal channel 2 output 1 and channel 2 output 2. To drive these two motors, we short jumper AF, AE and AD, AC respectively. In order to power the motors, we need to connect power supply according to the motor specification to the terminal V+ and ground. In this board, we also connect trigger pin from two ultrasonic sensor to AA and AB respectively. This is how fully assembled stack looks like. And the final assembled system looks like this.
Visit www.e-lagori.com for more details.